bit. Today, I won't be talking too long. Stop share my screen. All right, so we are going to be talking primarily about the exam, the upcoming exam, and hopefully you all saw the announcement that you with the practice exam. And before you totally freak out about that, the practice exam is meant to be much longer and more difficult than the actual exam. So I'm going to briefly open up the actual exam, not to have you see any questions, but so you can see the rules for the exam. And please keep in mind that the practice exam, again, is much longer and more difficult because I want to give you more chances to practice on problems. Okay, make sense? So perhaps it's bad to call it a practice exam at this point and more like a bunch of problems that I'd toss on an exam in an alternate universe. Okay, so exam is on the 15th, right? I will make it available at the appropriate time. Now just zoom in so that I can, yep. All right. Yeah. So the instructions and permissions for restrictions for the exam is as follows. Remember, this is done in lab, so you'll have access to a computer. So in general, this is an open note exam with a few caveats and expansions on what a note is. It is also open computer, but not open internet. It's very restricted internet. And essentially the rules are there just to say, you can't Google an answer, but in more detail, okay? So you can complete the exam on your own device or on the lab computer. Either or is fine. Any device you want to use. If you want to use like an iPad in conjunction with your computer, totally cool. I don't really mind. Whatever device you feel most comfortable or most able to code in. Students may use any coding environment of their choosing, such as, but not limited to, IntelliJ, Eclipse, NetBeans, Atom, VS Code, Vim, whatever tool you normally use to code, feel free to do that. The exam is open note. Those notes may be paper or electronic, any amount of paper, any type of paper, that's cool. Just gotta actually be able to carry it with you. So like the Magic of the Gathering deck size rules, your card has to be minimum 60, but it can be as big as you want so long as you can actually shuffle it. Notes can be stored. Notes can also be notes or code stored on your computer or personal cloud OneDrive. So if you whatever's immediately accessible on your computer, cool. You want to download the entire Java doc? Sure. You want to download all linked list related questions from Stack Overflow and store them on your local computer? Sure. Put it on OneDrive, your personal cloud, whatever? Sure. The main point here is, again, I just don't want you to like search for like, if I'm asking you to merge two linked lists, I don't want you to search how to merge two linked lists, which is a common enough question, you know. There's only so many quality questions out there and which are really good at testing what you can do, what you know. And so I need to make sure that they are that you can answer them honestly. You can have access to any resource on the internet that is linked from Canvas, such as my YouTube lecture videos or the lecture recordings or my GitHub page. So feel free to, you know, use my lecture recordings during the exam if you need to. Just be sure not to, you know, play it on full blast or something. You know, headphones would be advised if you do that, or subtitles. Also, any kind of code I wrote in the GitHub repository, you know, which is the code for all those data structures. Convenient, right? Okay, you cannot use resources on the internet that are not on your personal cloud, nor those that are not linked to Canvas. Okay, so it's just, you know, this is the kind of rules I've come down to ever since I've decided to keep things electronic. I used to do them all on paper, but paper meant turns out there's people with handwriting almost as bad as mine. B, I don't have to worry about leaving things home. C, I don't have to worry about accidentally making an arithmetic error. I'd make at least one a semester where a student didn't get the points they were deserved. Now, of course, this was brought to my attention because I tell everybody to recheck their points, but you know, that can be like, oh, I thought I did so terribly, to okay, you know, it can be really emotionally jarring. And on number 4, I have a kid and I have cats, so and both things can create different messes in different ways. So don't want to tempt fate there. So, all right, let's just take a quick, brief look at the practice exam, which I will go over next Monday. Next Monday, I'll give you, I won't so much give you an answer sheet as I'll go over all the answers. There is an answer key, I think, under files. If you check this files tab, you should be able to find it, but it's not very verbose. It's just general kind of pointers. This is a drawing question, a bunch of stuff over here for what you need. These are more pseudocode kind of questions. So this is a question from, so you can expect them kind of like drawing what the code does question. And feel free to like take a picture with your phone and upload it if you need to. Here, this one is, this is representative of kind of question you'd get where you have a question that wouldn't feel out of place on lab 2. Make sense? Where it's here's a list, do something on it. Now tell me what the runtime of the algorithm is. Okay. So kind of a combination of assignment 2 and assignment 3, right? Similar over here. Write this question. Tell me what the assignment is. You'll have one of those questions. The exam is 7 questions long. We don't want to make it too long. I just want to give you plenty of practice here. Then there will be a bunch of stuff related to linked lists. The key here is to understand where you should, if you're writing inside a linked list, writing an add method or something internal to a linked list, that's kind of the point where you should be using pointers and stuff. So generally that means if you're working with an instance method, meaning stuff where you'd have access to head, tail, and the actual nodes, right? Outside of a linked list, you do not have access to nodes. And that's a good thing because working with individual nodes is painful if you don't have to. So like over here, the static linked list merge. And what you'll have on the exam is something along the lines of add a method, have a method. Like, so add a new method to linked list or special type of linked list. Okay, so like this count method, you'll want to write it, for example. That was my question. And then the second question will be like, okay, here's a new method that's static. Use the method you just wrote to complete the previous, you can use the method you just wrote to help you out. So merge, this one's a good one because it's part of merge sort. I'm also a big fan of this one because this is a former interview question that used to be given out, except everybody knows it now. So it's no longer an interview question. And now it's the archetypical linked list practice interview question because you can make it harder and harder and harder for the person doing it by just saying, okay, now, but what if you don't have this resource? This one I would definitely focus your efforts on, where you have a new type of linked list called the sorted linked list, which automatically keeps all items sorted. So it's a linked list, but you're not adding to a specific index. You're adding to, you're adding on its own, or it figures out on its own. Also note that it has a restriction. It's got to run in O of n time. On the exam, there will be a question that says, hey, this method, it's got to run in O of n time, 5 points if it doesn't. If you're having trouble, take the 5-point loss and get something on the board, okay? If you're having trouble with a problem, take the 5-point hit and write something that works in O of n squared time. That's okay. It's 5 points out of 100. It's not a big deal. In general, this is actually advisable also for interviews. In general, in interviews, a lot of problems have like a solution that takes a ridiculous, that's like naive, but quick to put on the board to show that you understand the problem. Even if and you want to put it on there, even if it takes like factorial time to do. The truth, so, or O of n squared time. And then there's generally a much more efficient solution that's a bit harder to get to. But by showing that you can do an inefficient solution, you can, if you show you can do an inefficient solution, then you show you understand the problem. And that's good. Because that's a big part of what we're trying to do. And last, as I've mentioned near the end of the last class, we will have this question. This question will be on the exam, just slightly phrased differently. Okay, it's 20 points. It will also be 20 points on the exam. A list can be implemented in any number of ways. Compare and contrast array lists and linked lists. In which situation would you implement one list over another? On the exam, I'll phrase it differently, but what I'm looking for is a comparison between the way that the two different lists will waste memory because they waste memory or have an overhead memory cost that works a bit differently. Then also their add and remove, right? Those are symmetric, right? One is good where the other isn't. And same with get set. Those are good where those aren't. So you want to use, and you want to phrase it in terms of big O notation, because that is absolute. That gives me an absolute kind of way of figuring out how that works. So, right, memory, add remove pair, get set pair. And yeah, that's 20 points. So totally have an answer ready for that because, you know, you should. And I tell that to students. And I still get students who get it like completely wrong. Typically, the way it works is I get a lot of people who do the breakdown of points is typically 20 points, 19 points for like accidentally writing something wrong, but it's an obvious accident where they put a 1 instead of an N, right? Where they just didn't proofread. But it was pretty obvious. 16 out of 20. 19 out of 20, 16 out of 20, where in the 16 out of 20 is where people forget the except cases, right? It's this time, except when. And then like 13 and lower is when they botch one of the parts completely. So, it, take the time to, to have an answer prepared. Otherwise you're just leaving points on the table. It's all about preparation. Preparation is key. Like, okay, I've got a question in chat. Okay. No worries. That was not a question, that was a comment. Okay, so all right, so any questions about the exam? Oh yeah, and I forgot to mention this in the morning session, right? So it is 2 hours, you get basically your hour and 50 minutes, the full time, okay? After that time is expired, there's a late penalty for the exam, right? It won't shut off on you. The late penalty is as follows. 0.1% per minute late. That means you turn it in an hour late. How much is that? 6 points off. So worst case scenario, follow the TA to wherever they need to go and then resume. Okay. But if you have some kind of issue which prevents you from finishing the exam within a good amount of time, or you can't make it to school, like if there's a complication that comes up, just let me know. Don't try to, let me know as soon as something comes up. When it's easier to do it that way. And for God's sake, like if you are not feeling well, don't come in because you shouldn't in general, just send me an email, right? And this happened last semester. If you have like a death in the family, like the day before or the morning of, do not come to the exam. You probably aren't in a good space to be making decisions in the first place, which is why the person, kind of went on autopilot and went to the exam. But do not come to the exam if like something terrible happens to you, because it's not going to be an accurate representation of your skills. And that what the exam is meant to be, an accurate representation of your skills in a confined environment where you can be monitored and we can be sure that it isn't somebody else doing your work for you. That's really what it comes down to. All right, so any questions? Otherwise, I'll be happy to take demos and questions. We will talk about the maze problem on the module 5 problem on Wednesday. It's not necessarily the maze problem isn't too bad. You follow the pseudocode and you should be able to solve it. But it's worth talking about because mazes are fun.